The purpose of this video is to review for the upcoming exam, test number 1. Remember that a relation is a set of ordered pairs. The domain of a relation is the x coordinates, and the range is a set of y coordinates. So we want to determine whether the relation is a function. In this relation, we have 5, 0, 8, 1, 1, 3, 5, 2, and 3, 8. You notice that the x coordinate 5 is paired with both 0 and 2. The relation is not a function. The domain is a set of x coordinates, which is 5, 8, 1, and 3. And then the range is a set of y coordinates, 0, 1, 2, 1, 3, 2, and 8. On a separate sheet of paper, you're going to have to answer the questions. I'm just going to give you one example from 4, 5, 6, and 7. I'm going to select 7. That's a mapping. We know that we have in our domain, we have -2, -1, 1/2, and 3. In our range, we just have 2. Now the question goes, since every value is paired with 2 in the range, can this be a function? And the answer to this is yes, it is a function. For number 8, I'm going to go ahead and read the instructions. It says, for each function, find f of -2, and then we have to find f of -0.5, and then we got to find f of 3. So remember that you're going to use the equation that is given to you. So like for number 8, we have f of x equals -x plus 4, and I'm going to write this down. We have f of x equals -x plus 4. So what you're going to do is you're going to replace the x with the input. In this case, you got to be careful. You have a negative, and then you have a -2 plus 4. So when you have a minus and a -2, that becomes a 2. So you have 2 plus 4 gives you 6. So the input is -2, the output is 6. Now for f of -0.5, we have a negative, and then we have a -0.5 plus 4. That is actually a positive 0.5 or half plus 4, which gives you 4.5. So the input is -0.5, the output is 4.5. And then the last one, we have 3. So we have a negative, and then we have our input is 3 plus 4. So it's -3 plus 4 gives you 1. So I just did number 7, and I also did 8, but I am requiring you to do 4 through 9. And on a separate sheet of paper, you have to show your work. I would like for you to focus your attention on the example. I know that I didn't describe or I haven't gone over asymptote or x-intercept, but I want you to direct your attention to the example. There you have a cubic function. It says, what is the range of the cubic parent function? F of x equals x cubed. And so what you're going to do is you're going to graph this either on Desmos or TI Inspire. And you notice that when we talk about the domain, it's going to be the set of all x values. And then when we talk about the range, we're talking about the set of all y values. And you notice that the lowest y value is actually -infinity. And you notice as we go from right to left, this graph is decreasing and the y value is approaching -infinity. As we go from left to right, the y value is going to positive infinity. So what's the range? The range is a negative infinity to positive infinity, and it's going to be the set of all real numbers. All real numbers. Your instructions are to do 10, 11, 12. You're not required to do 13. Then I want you to do 16, actually 14, and 16. Okay, and I think 18. Oh no, yeah, 18. Okay, I will probably end up doing all these problems with you. So I'm going to go ahead and pause it. I do want to let you know for problems 10, 11, and 12, the best way to determine the domain, the range, and the intercepts is to graph using Desmos or a T-Inspire, and we're going to work on that right now. I'm going to sketch that. And then from 14 and 15, I want to say 14 and 15, no, 14 and 16, we're going to do that using Desmos, okay? And then we're going to talk about 18. I'm going to read the instructions. It says find the domain, range, and intercepts of each function. So I'm going to write, I'm going to go ahead and do number 10. I know that I have x plus 3y equals -1. You're going to isolate the y variable. So you got to subtract x from both sides. You're left with 3y equals -x minus 1. And then what you do next is you divide by 3. So you have y equals -x divided by 3 minus 1/3. So in order for you to graph this, you have to solve for y. You subtract the x from both sides, and then you have to divide by 3. What I'm going to do now is I'm going to pause it, and then I will come back and we will graph this, and we'll look at the graph for the intercepts, and we're also going to find the domain and range. I'm going to sketch this, and you're probably going to wonder, okay, how did he do this? I used Desmos. You could have used the Inspire. This is your y-intercept, which is going to be -1, 0. And this one here is your, I'm sorry, that is your x-intercept. This is your y-intercept, which is 0, -.333, and you know that that is -1/3. So this is the x-intercept, -1, 0, and the y-intercept is 0, -.333, that's 1/3. What is a domain? Remember that the domain are the set of x values, and you notice that it goes forever from left to right. So it's actually from negative infinity to positive infinity. The range is actually starting from the lowest y value, all the way, and it continues going, because we know that the arrow tells you goes in either direction. So it's going to be from negative infinity to positive infinity. Number 11, we have f of x equals 2x to the third power. So what you're going to do is, well, if you go to Desmos, you can automatically type in f of x equals 2x to to the power of 3, okay? And what I'm going to do now is I'm going to sketch my graph, okay? And I should have labeled the y-axis and I should have labeled the x-axis. There's the y-axis, there's the x-axis. So this is the graph that I do see on Desmos. You notice some differences between the two. There's actually two intercepts there. For us, the x and the y-intercept are the same. It's actually 0, 0. Now we got to find the range and the domain, which we're going to go ahead and highlight. This will tell us the set of all x values. You notice it goes from left to right. They go on forever. And we know the range is a set of y values, and we know that it's going to go from the lowest y value to the highest y value. And you notice that the domain is actually from negative infinity to positive infinity. As we go from left to right, it's actually all the x values. The range is also all the y values. So it's negative infinity to positive infinity. Both answers for domain and range can be also called the set of all real numbers. I'm going to pause it, and I'm going to go ahead. If you have any questions, make sure that you do text me on Remind or make a note so you can ask me in class. All right, we're going to go ahead and do number 12. And so we have number 12, and we have f of x is equal to negative x squared. I'm going to go ahead and go to Desmos. And I'm going to graph this equation, which happens to be a quadratic. And I do know that it goes like this. Okay, I'm going to pause for a minute so you can see it. We have to identify the intercepts. So what is the x-intercept and what is the y-intercept? And if you said they're the same order pair, then you're correct. It's the origin, it's the same order pair, okay? So now we're going to talk about the domain, and I'm going to use the highlighter to indicate that I'm going to start from the lowest x value and go to the highest. So you notice it continues. So what is that going to be? It's going to be from negative infinity to positive infinity. Some textbooks or some teachers will say all reals. The range is different, and I want you to notice the difference here. We know that the lowest y value is actually negative infinity, but it stops at 0. So what's going to be the range? So I'm going to use interval notation. I know that the lowest y value is negative infinity. And you're right. What is the highest y value? In this case, it's 0. Now, if you wanted to use inequalities to describe this, what is the variable that you use to describe, or what do you use for for range? It would be the y value, right? So it's all the numbers less than or equal to 0. For number 14, it tells you that it says, find the minimum and maximum values of f of x on the given interval if each value exists. So if we have f of x equals 2/3, and we ask what is the max value and what is the minimum value, we'd have to look at the graph, and I'm going to go ahead and sketch the graph here. We know that the graph will be a horizontal line. This would be y equals 2/3. And I'm going to stop so you can think about it for a minute. The max and the min will just be that horizontal value, that y equals 2/3. What I'm going to do now is I'm going to go ahead and do number 16. We're going to find the max and the min for this function number 16. So we have 16. I have f of x equals x minus 5 divided by 2. And they do give us an interval from x equal -3, and I'm just going to select some x values, -3, -2, -1, and 0. So the interval is from -3 to 0. Now we got to find the y value. And what you can do is either you can show your work or use a calculator, use Desmos. I'm going to go ahead and use Desmos. So I'm going to pause it. Now these are not all the values in this interval. I just selected a few, so I just want you to notice that there's a pattern. At x equal -3, the output is -4. When x is equal to -2, the output is -3.5. When the input is -1, it's going to be -3. And then when it's 0, the output is -2.5. So just by looking at the table, even if I were to list all the possible values between -3 and 0, my highest would obviously be x equals 0 because the output would be -2.5. The lowest will always be input -3, the output is -4. So this is your max, that's your max point, and there's your minimum value, your max and minimum value. Number 18, a classmate says that f of x, and I'm going to go ahead and put 18, that f of x equals -x to the 3rd power. And your classmate is saying that the range is going to be y less than or equal to 0. What you can do is you can graph this on Desmos. And if you were to graph this on Desmos, you would notice that the graph will tell you the true range. And let me go ahead and graph that. So here you have the y-axis. Here you have the x-axis. And of course, you have a -x². So I would highly recommend that you do this in Desmos. And you notice that by just looking at the graph itself, we're looking at the set of y values. You notice that the range is actually from -infinity to +infinity. It's actually all the set of values from -infinity, +infinity. So obviously, your classmate is wrong, okay? This is the last section that we did before we're going to take the exam. It says, a quick review. When performing function operations, you can use the same rules you use for real numbers, but you must take into consideration the domain and range of each function. And out of this section, I would say the hardest is this composition. And so we did spend some time on this. Remember that you got to remember what are your functions. In this case, we have let f of x equal x plus 3. We let g of x equal x squared minus 2. Now remember, that circle does not mean multiplication. It means that you are going to pass the output for f of -2 into g. So you notice we have f of -2, And the output of f of negative 2 is negative 2. So negative 2 plus 3 is 1. So now that is the input for g. And then the output is negative 1. So we have g of f of negative 2 is negative 1. So what I'm going to do is I'm going to go ahead and do some selected problems. I'm going to probably do 22. And I did ask you to do 20 through 22. And then I'm going to do 24. I'm going to do 24, and I'll probably do 27. So the hardest thing out of this whole section was composition. Let's go ahead and read the instructions. We let f of x equal x minus 4 and g of x equal x squared minus 16. Perform each function operation and then find the domain. So for 22, we have f of x times g of x. So I'm going to get f of x, which is x minus 4, and I'm going to multiply times x squared minus 16. And what I'm going to do is I'm going to apply the FOIL method. So we have x times x squared, which gives you x to the third power, x times negative 16, which gives you negative 16x. I'm going to multiply negative 4 times x squared, which gives you negative 4x squared. And then negative 4 times negative 16 is 64. So now I got to write it in the correct order. So I'm going to start with x to the third power. The next one is minus 4x squared. The next one is minus 16x plus 64. So now I got to find the domain. So what I'm going to do is I'm going to use Desmos to find the domain. So I'm going to pause it for a minute. I went ahead and used Desmos, and this is what I got. I got something that looks like, I'm just going to sketch it. This is the y-axis, this is the x-axis, and it looks something like this. Now you notice if you want to find the domain, we're looking at the set of all x values. We notice we're going to start at the lowest, which is negative infinity. Lowest x value is negative infinity. The highest x value is positive infinity. So what is the domain? From negative infinity to positive infinity. So now we're going to do the next section. It says let g of x equals 5x minus 2. So what I'm going to say is I'm going to say g of x equals 5x minus 2. And then I'm going to go ahead and do 24. So h, we know that h of x is going to be x squared plus 1. So we're looking for this h, and then you have this little circle, g. That means composition. So h of g of negative 1. So let me rewrite this. So you have h, and you have g of negative 1. So you're probably asking yourself, what do you have to find first? You need to figure out the output for g of negative 1. So I'm going to go ahead and I'm going to do the work here in the bottom. I have g of negative 1. So what is the input? The input is negative 1 into g, so you get 5 times negative 1 minus 2. So 5 times negative 1 is negative 5 minus 2 is negative 7. So now you have h of whatever the input is, which is actually the output of g of negative 1. So that's going to go in here. So it's h of negative 7. So let me go ahead and find h of negative 7, which is the input is negative 7 into h. So you have parentheses squared plus 1, because that's h. Let me go ahead and highlight that. You're probably saying, where is h? H is up here. I'll use a different color. This is h. Okay, so We have h here, but what you got to do is you got to show some work here. So this is where we're showing our work. And you notice we have a missing value there. What do you have to put in there? Negative, you have to put in there -7, because that is the input, -7. That is the input, -7. So what do you get? -7 to the second power is 49. Plus 1 gives you 50. So the actual h of g of -1, the final answer is 50. Okay. So now we're going to do 27. So we're going to start out by writing 27. I know that g of x gives you 5x minus 2. I know that h of x gives you x squared plus 1. Those are our two equations. So now we got to determine g, little circle. That little circle means composition. And now we're going to input a variable called a. Okay. So let me go ahead and do some rewriting here. I have g parentheses h a. So let's take a minute and let's figure out what we have to do first. So we got to look inside the parentheses, and I'm going to highlight that. You have h, function h, that will take the input of a. So I have function h that will take the input of a. So I'm gonna use the red pen to show the work. So you have h of a equals parentheses squared plus 1. So what do you put in there? You write a. So what will be h of a? Well, a to the second power is a squared plus 1. So now we have g, and the input is a squared plus 1. Okay, yeah, that's right. It's going to be an expression. So we're going to go to g, and I'm going to use a blue marker or blue pen to figure out g. So you have g. The input is a squared plus 1. So what do you have? 5 parentheses minus 2. So what goes inside that parentheses? That's correct. A squared plus 1. And then what we're going to do is we're going to go ahead and do some cleaning up. So you have 5. You do the distributive property. 5a squared plus 5 minus 2. So what do you have? 5a squared plus 3. So what comes out eventually? What is the final g of h of a? It's going to be 5a squared plus 3. It's going to be 5a squared plus 3. Okay? It might take you a couple of times to go through it, but eventually you will understand the pattern. If you have any questions, please let me know or come in for tutoring.